I chose to implement the problem of the longest common substring. This problem arises whenever we search for similarities across multiple texts. A particular and a very important application is in finding this similarity among DNA sequences. The genes for building particular proteins evolve with time, but the functional regions must remain consistent in order to work correctly. So by finding the longest common substring of the same gene in different species, we learn what has been conserved over time. And I found it to be very interesting, and this is why I chose to address this problem. So, for example, if we are giving a set of strings AB, AB, BA, BA, and AB, BA, we can of course see that the longest common substrings are AB and BA. To solve this problem, I've implemented two different algorithms. One is by using suffix trees, and the other one is using the notion of dynamic programming. So in case of the suffix trees, we can build for a set of strings a suffix tree, and then we can find the deepest internal nodes which have leaf nodes from all of the strings in the subtree below it. So here in this example, the common substrings are A, AB, B, and BA, and all of them have descendants leaves from all of the strings numbered 0, 1, and 2. So for example, AB have 0, 1, and 2 descendants leaves. After we find all the common substring, we can find the longest one of all. In case of dynamic programming, we can build this matrix for each pair of the input strings. In this case, we can see in the diagonals the longest common substrings, ABA and BAB. So in my project, I have LCS, the model, the interface, and it has type strings that holds the input strings, and two main methods. The build strings method that build the structure. In case of the suffix trees, it will be a suffix tree, and in case of the dynamic programming, it will be matrix. And the other method is the longest substring that passing the structure, and we'll get back the longest substring. So, for example, if we'll start with the suffix tree implementation, we'll use the build strings to build the structure, the tree, and we'll give it a list of strings, two strings in this case, that represent a sequence of amino acids, and then we'll get back the tree that will pass to the longest substring method, and we'll get back str, the longest common substring. Hopefully, here it is. This is the longest common substring, and we can do the same for the dynamic programming model. And we quickly got back the same result. So in addition, I've also made a comparison between the two algorithms and made a time complexity analysis as well. Thank you. That's all for now.